Hello again, and welcome to this next short video about the flight computer. My name's Andy Sinclair, and I'm a flight instructor with the Bristol Ground School PPL Ground Studies team. In the last video, I introduced you to this flight computer, this device, and we looked at the circular slide rule side. In this video, I'm going to flip the device and we're going to start to take a look at what's called the triangle of velocities or the wind scale side. I'm using this CRP5. The techniques will work for a CRP1, ARC1, and an E6B. The wind scale side of the computer is used to graphically solve triangle of velocities problems. So let's have a quick look at the parts of the device. So we have at the top there, we have the index mark on the outer fixed ring. We have the center dot. We have the rotating inner ring and movable window, meaning that the plastic covering between the on top of the graph paper, for want of a better way of putting it, moves when the inner ring moves. We also have curved speed arcs and straight drift lines. Those are the component parts. A triangle of velocities problem is simply a matter of calculating the resultant of two given vectors. One of the given vectors being the track across the ground you wish to follow. The phrase is track made good. Sometimes that's called the course you wish to follow. Because it's a vector, it has both direction and magnitude, both scalar quantities. In this case, the magnitude is the true airspeed. The other vector is the wind velocity, which again consists of two components, the wind speed and the wind direction. The resultant of these two vectors will be the heading, meaning the direction the aircraft needs to be pointing in order to make the track good or to follow the course that you wish the aircraft to follow. It will also, as a magnitude, give you a resultant ground speed. Now, the aircraft heading is not the same as the aircraft track, simply because the aircraft may be traveling through the air sideways or crabbing along. And indeed, if the wind is directly on the nose or directly on the tail, that's exactly what will be the case. So first thing we need to do then is to put the wind on the wind scale side. This is done in one of two ways, or can be done in one of two ways, either the wind up or the wind down method. Take a look at the diagram here. It shows the wind added using both these two methods. Take your time to look closely so you can see how the wind has been added. The inner ring has been rotated so that the wind direction is aligned with the index mark. That's the same in both cases. But in the wind up case, a wind line is drawn up from the center dot and marked with an X. In the wind down, a line is drawn down from the center dot and marked with an X. The length of the line is the magnitude of the speed of the wind. The index mark aligned with the outer ring is its direction. So that's the wind put onto the wind scale side. Note that whilst the direction of the wind will be the same in both cases, the graphical result will be different. When the inner ring is aligned with the required track, in the wind down method, the wind vector is shown representing the effect of the aircraft being pushed by the wind. And in the wind up method, the vector represents the effect of the aircraft being pulled by the wind. There are advocates for both of these different methods. Advocates of the wind up method argue that their method is simpler because there's no necessity to balance the drifts caused by the wind and heading to obtain the resultant track. And that's true. But advocates of the wind down method respond by saying, well, marking of the wind in this sort of reverse fashion, the wind up fashion, means that more complex wind velocity problems cannot be solved. That's also true. My advice, folks, is stick with the wind down method, as you can bet your bottom dollar that in the exam you won't be faced with a simple, here's the wind, here's the track you want to achieve. What's the required heading? And what will the ground speed be? The questions are more likely to be, you notice that you are tracking this direction and heading that. What's the wind? Of course, the wind up method will not help you solve that vector problem. The wind down method will. Okay, so now we have the wind on the flight computer. Next time we'll discuss adding the required track. Cheerio for now. Bye.